So we'll be doing revision right now. Okay. I know we are about to complete fluid dynamics. I think it's now left of 2 or 3 hours. But yeah, we'll be doing revision. Waves and sound is our motive. So we'll complete revision of that and we'll attempt questions from here. And right now it is 6 o'clock. Okay. Till 8 o'clock we'll do revision. Then I will take a half an hour break. And after that 9 to 10:30. Okay. So this is my plan. Let me open paint and type for you guys. You know, we could add sticky notes. I don't know how to do that. Okay. So I'll be opening paint. Hmm. Can you guys see my screen? I hope so. We do can type here, right? Where is that option? Yes. I want a bigger size. What? I've not used plain paint for quite a longer time now. So I don't know. plan for today. I'm gonna do this thing that I will shift my this box from here to here only. This was more convenient for me, and this is more convenient in this way. A little hush hush. Hmm. What just happened? I wrote my whole plan. Okay, let me just write. I think this is fine. Readable enough. Or black only is fine. I think that is fine. Okay. I'll be starting with my revision. This is my all subjects revision notebook. Ah, a little hodgepodge has happened. मेरे को ये study table भी कम पड़ रहा है. I don't know why, for what reason I'm feeling very thirsty. I'll order green pens now for revision. So we're gonna do waves. Okay. So wave is the disturbance from equilibrium position which travels. Okay, it is a disturbance which travels. So disturbance is the one which is traveling in this. If you so in this particle does not move basically according to them. It just oscillates. Okay. So wave is a form of energy. transfer or momentum transfer. Okay. So now disturbance can be in various forms. Okay. Disturbance can be like pressure का disturbance या displacement का disturbance हो गया है, density का है, or we have electric and magnetic fields. So these four can be the disturbance. Now types of waves. इतने घटिया पेन मत खरीदना कभी. Telling you seriously. So now we have two types of waves. I do not have a sharpener with me. Oh my god, this is ridiculous. We have two types of waves, mechanical or non-mechanical. Okay. So mechanical is a wave which requires a medium to travel. This requires medium to travel, and this does not requires medium to travel. Okay. So example for this is sound waves, waves of strings, or waves in air column. Example for this is light waves. लाइट वेव्स ऐसे याद रखना वो नॉन मैकेनिकल है क्योंकि स्पेस से हमारे पास जो सनलाइट आता है उस चीज से यू पीपल कैन recognize, right? So next is transverse wave and longitudinal wave. So what is transverse wave? Transverse basically perpendicular के लिए यूज होता है. So oscillations which are perpendicular to the direction of wave is transverse wave, and which move same direction as wave is longitudinal waves. Okay. Example for transverse waves is wave on a string, EM waves, or light waves. Example for this is sound wave in an air column. Just a second, it requires. Okay. Then B is transfer waves are only visible in solids and liquid surfaces. Liquid surfaces. This is possible in all types. Possible in all mediums. Okay. Now we have is something known as general equation of wave, which is equal to y is equal to so we have a general equation of wave where y is the displacement of particle. Okay. And here y is basically a function of time and y is also a function of x. Okay. So basically y is function of both t and x. So the equation of y is equal to function of ax plus minus b t. Okay. For this to be y, we can find velocity of wave which is equal to b upon a. Basically coefficient of time by coefficient of x. So what and all we have studied till now is that in waves, disturbance level, the particle does not. Particle just oscillates. Okay. Okay. Then we have studied the types of waves, which are mechanical and non-mechanical. What are mechanical, which requires medium to travel, and non-mechanical are which do not require medium. Example of mechanical is sound waves, waves of strings, and waves in an air column. This is light waves, then transfers, and then longitudinal, and this. Now a proper equation of y is a sine kx plus minus omega t. So this is for plane progressive harmonic wave. Okay. Now this equation is very important, whereby is equal to a sine kx plus w minus omega t. Okay, how is this now important? So here we have y is displacement of the particle, a as the amplitude, and k is the wave number. Wave number is equal to k, which is equal to 2 pi upon lambda. So this is 2 pi upon lambda. Then we have omega, which is angular frequency, which is equal to 2 pi f, or 2 pi upon time period. Okay. So velocity of wave, as we discussed, is coefficient of time upon coefficient of x, that is omega upon k. So this omega upon k gives you 2 pi f upon 2 pi lambda, which gives us f lambda. So velocity is equal to frequency into wavelength. This is actually very important because velocity बढ़ा रहे, frequency बढ़ रहा है कि नहीं बढ़ रहा, all those kind of things. Now we need to know direction of wave. So what is direction of wave? If omega t plus kx or minus omega t minus kx, if both have same sign, then we have negative displacement, negative wave, or whatever you call it, negative direction of the wave. If we have opposite direction, then we take positive. Okay. So opposite sign if they have, then it is a positive wave direction. Now we need to know is wave velocity. What is wave velocity? So wave velocity, as we discussed, is angular frequency upon k, which is coefficient of t upon coefficient of x, which is equal to frequency into lambda. Now this wave velocity depends upon medium. Okay. Similarly, the frequency and the wavelength. Wavelength also depends upon medium. So velocity and wavelength will vary with medium, but frequency can stay same. So frequency changes with change in the source. Okay. Okay. We have a question here. A transfer wave propagating along x-axis is represented by y-xt is equal to 8 sine 0.5 this and the speed of the wave. So they have given us equation of the wave. 8 sine 0.5 pi x minus 4 pi t minus pi by 4 they have given. They are telling us to find the wave speed of the wave. Hmm. So velocity is equal to omega upon k. Here omega is 4 pi and k is 0.5 pi. Pi and pi gets cancelled. 8 is the answer. For correct answer, I give myself star. Moving on to the next question. The wave described by y is equal to 0.25 sine 10 pi x minus 2 pi. He is a traveling wave along. So they're asking us the direction of the wave in this question. Okay. So since we have opposite signs in this, so the direction will be positive x axis of the wave. Okay. Next question. A wave traveling in the x positive direction having displacement along y direction as 1 meter, wavelength 2 pi m, frequency this is represented. So they have given positive x direction, which means opposite signs. Okay. They have given y as 1 meter and not y as 1 meter, it's a as 1 meter. Lambda is given by 2 pi m, sorry, 2m, and f is given as 1 pi. So they're asking us the question of the y. How do you find that? See, we know y is equal to a sine kx minus omega t. Y is equal to this. This is 1 sine. We don't know k, but we know k is 2 pi by lambda. So k is 2 pi by 2 pi. This and this gets cancelled. So k also is equal to 1. So x minus omega is equal to 2 pi f. Frequency here is 1 hertz, 1 by pi hertz. So omega is equal to 2. So 2t. As this is a correct answer, so I'll give myself a star. A wave in a string has an amplitude of 2 centimeter. The wave travels in the positive x direction with a speed of 128 meter per second. It is noted that it completes 5 wave fit in 4-meter length. Okay, this is an important thing to be learned now. First of all, amplitude is given 2 centimeters, so this will become 0.2 meter. They've given us velocity and also told that if 4 meter is the length, then it has 5 complete waves. It means 5 lambda. So from here, just you get is 5 lambda. Lambda is equal to 4 by 5. Okay. So from lambda, we can find k 2 pi lambda, which is 2 pi 4 into 5, which is 10 into 3.14 upon 8, sorry, 4, which is 7.8. So K here is 7.8. Okay. How come is frequency 105T? That is one of my doubts. First of all, this will come as 0.02. So I think this has been picked through option because that's what an answer we have got here. What is phase and phase difference? Okay. So phase and phase difference. Phase difference is donated by delta F. So we know the equation of the wave is y is equal to a sine omega t plus kx plus some phase difference, which is phi. Now, what is the difference between phase and phase difference? This equation, this we have sine theta. Here, theta's value is omega t plus kx plus phi. This entire theta is known as phase. In this, the value of phi keeps changing. Sometimes it is 0 and sometimes it is something else. This represents phase difference. Okay. So we will be having two equations like y1 is equal to a1 sine omega t1 plus kx1. Okay. And then we'll be having y2 is equal to a2 sine omega t2 plus kx2. This is our phi 1 and this is our phi 2. If I need to find phi, delta phi, then how do I find it? It is phi 2 minus phi 1. This will contribute to the phase difference, which is equal to kx2 plus omega t2 minus kx1 plus omega t1. This will contribute to the phase difference. Okay. But what if, till now, whatever you guys have studied is that it is sine theta. But what if it is given in cos theta? Okay. So, if it is given in cos theta, just remember how to calculate delta phase for those kind of cases. To calculate delta phase in terms of sine, you need to convert cos in terms of sine. Correct? So how do you do that? If you want a positive cos theta or a positive cos theta is given, then you just simply add 90 degree to sine. So it will be sine theta plus pi by 2. And if it is minus cos theta given, then you just simply subtract. So if it is positive, then you just add, and if it is negative, then you just subtract 94 pi by 2. And why do are we subtracting? Do you remember in trigonometry we do use this conversion from sine to tan, sorry, from sine to cos and tan to cot. We use a 90-degree conversion, right? So if you have a positive given here, you use positive. If it is negative, you use negative. That is how you can remember this trick. Next is we have some question. Two waves are represented by the equations y1 is equal to a sine omega t plus kx plus 0.57. Okay. And y2 is equal to a cos omega t plus kx. Okay. So we need to find the phase difference between both of them. Phase difference is delta phi, which is phi 2 minus phi 1. For that, I have been given cos theta here, that to a positive one. To convert it into sine, I need to write it as sine theta plus pi by 2. So here, my y2 becomes a sine omega t plus kx plus pi by 2. Now, these are my equations for y1 and y2. Okay. So, to calculate the phase difference, which is phi by 2, phi minus phi 1, which is equal to omega t plus kx plus pi by 2 minus omega t plus kx plus 0.5. This and this gets cancelled. We are left by pi by 2 minus 0.57, which is 3 by 1 4 minus 0.57. 0.57 into 2 is 1.14. 3.4 minus 1.14 is 2. 2 by 2 is 1 radian is the answer. Okay. As this is a correct answer, so I'll be giving myself a star. Next question. Sorry, next topic. Till now, whatever we have studied is somewhere between a particle and a wave. Okay, so now this will make you more clear what you have studied. So a wave velocity and a particle velocity. Okay, so what is a wave velocity and a particle velocity? First of all, we know is y is equal to a sine kx minus omega t. What is a y here? Is it a particle displacement or a wave displacement? This was a displacement of a particle. Correct. We know velocity is equal to dy by dt. Correct. So if I differentiate this y, then what will I get? Wave velocity or particle velocity? Definitely particle velocity. Why? Because here y represents the equation of particle displacement. So if I differentiate this, we get Vp, which is particle velocity, as minus omega a cos kx minus omega t. This you get as particle velocity. But what is a wave velocity? We have studied wave velocity, which we do get from the equation of the wave itself, which is frequency into lambda is the wave velocity. If I need to calculate Vp max, how do I calculate? If I put cos theta as 1, then I get omega a. First of all, we will not put cos theta as 1 here to keep it maximum. Here cos theta should be minus 1 to be this to be maximum because we have a negative sign. Okay. So basically we get this maximum value when the wave passes through mean position. Okay. Also, at its zero position. I don't know who is the second person watching the live. Can you like comment down? I don't know if it is Karthik or anyone else. So, what are the formulas which we have studied until now? I'll be putting a revision for the formulas. So, what are the formulas which we have studied until now? My phone battery is gonna get down. So, in another half an hour, I'll change the angle, okay? So, we know Vp is equal to dy by dt, which is equal to minus a omega cos kx minus omega t. We know the maximum value of Vp is omega a. Okay. Next are few questions. I don't know how much we'll be able to cover in 1 hour. We'll try our max. But to that. Okay. So next is a question. A transfer wave is represented by y is equal to a sine omega t minus kx. For what value of the wavelength, the wave velocity is equal to maximum particle velocity. Okay, so they are asking me a question that v wave is equal to vp max at what lambda? Correct? So how do I calculate? What is v wave? Omega upon k. What is vp max? Omega a. Okay. So from here, omega and omega gets cancelled. So I am left with 1 by k is equal to a. From here, k can be represented as 2 pi lambda. So this becomes lambda upon 2 pi is equal to a. They asked me to find lambda. So lambda is equal to 2 pi into a. That's it. The equation of an S for a simple harmonic wave is given by y is equal to 3 sine pi by 2 50t minus x. Where x and y are in meter and time, the ratio of maximum. Okay. So here they are asking me ratio of Vp max upon V of wave. So how do I calculate that? I know Vp max is omega. First of all, omega is 50. So Vp max is 3 into 50. That is 150. But wait, we have a pi by 2. So omega will not just be 50, it will be also into pi by 2. Pi by 2. Some 750 this should be. Okay, we'll just leave this here. 3 into 50 into pi by 2. Then we have is v particle velocity, sorry, wave velocity, which is omega upon k, which is 50 into pi by 2 upon k is equal to pi by 2. Okay. So simply Pi by 2 and pi by 2 gets cancelled, and I'm just left with 50 here. If I need to find this, then I'm just left with 3 pi by 2 is the answer. Now something important. Relation between wave velocity and particle velocity. Okay. We know Vp is equal to minus, okay, so the relation is Vp is equal to minus V partial differentiation of velocity with x. Okay. This is the slope and this is the wave velocity and this is the particle velocity. If I do sketch this on a graph, I get a sinusoidal wave. Here slope is partial differentiation of velocity. Sorry, displacement. Okay, now this is important. We have this. Here we have points A, B, C, D, and E and F. So from O to A, the wave is going up, correct? And because it is going up, but because of slope and a negative sign here, particles will go down until point A. Now the wave from A to C is going down. So because of this negative sign, particle will go up. So from here, we got particles as going up. Again, from C to D, the wave is going up. Because of this negative sign, it will be coming down. Again, from E to F, the wave is going down. And because of this negative sign, the particle will go. Okay. A transverse sinusoidal wave moves along a string in the position x direction at a speed of 10 centimeter. So wave at a speed of 10 centimeter. Okay, wavelength is given as 0.5 meter, amplitude as 10 centimeter, and at a particular time, the snap of time, the wave is shown in the figure. The velocity of point P when its displacement is at 5 centimeter. So here they have given that the transverse sinusoidal wave is moving. So wave is moving means they have given wave velocity which is 10 centimeter per second. Okay. Lambda is given, A is given. Okay. And they have also given us the graph. And this is the point P. As you can see, the slope is going down, so the particle will be going up. As slope is down, so Vp will be up. So it will be somewhere in positive J. Okay. So from the options they have calculated, and this you get as 350 pi J meter per second. Figure shows the wave as y is equal to a sine omega t minus ax. What is the magnitude of the slope of the curve? They have also given us the graph where B is the point. If I see this, I know slope is equal to del y by del x, and Vp is equal to minus V del y by del x. Okay. So if I do positive of this, del y by del x is equal to Vp by V, which is omega A upon omega by minus V. Because B is at mean position. And at mean position or 0th position, Vp becomes maximum. Okay. Omega gets cancelled and you get delta y by delta x is equal to K A. You guys have to remember that B is at this point. This or these points are the mean and the zeros positions, which gives you maximum velocity. Now we have studied about wave velocity and maximum velocity. We'll study about the acceleration of the particle. Okay. After this, we have intensity. Intensity is a very nice topic. It's actually a very nice and one of my favorite topics. Right now it is 6:46. I'll just come back in 2 minutes. Okay.